and analyzing data, right? So, in this case, actually, security-related events, logs from servers, firewalls, IPS systems, and many others, right? So, one of the main goals of data normalizations is actually to purge and delete redundant data and to maintain data integrity itself, right? So the normalized data is protected by making sure that any manifestation of the same data elsewhere is only making a reference to the data that is actually being stored. Another goal of security data normalization is to eliminate the risk of evasion techniques and ambiguities within your network, right? There are different types of normalization techniques depending on levels of increasing complexity. Now here I'm actually showing the 3 different types of data normalization categories that are mostly used in the industry, right? One is actually referred to as 1NF, which is the first normal form, and you can assume the following, right? So it's second normal form and third normal form. And these categories can continue to increase in forms and complexity depending on the requirements and the environmental needs of your organization. In the case of intrusion prevention systems, they focus on the throughput emphasis for the most rapid and optimal inline performance, right? So when doing so, in most cases, it's actually impossible for full normalization to take place, right? Traditional IPS devices often relied on shortcuts that only implement partial normalization and partial inspection. This, of course, increase the risk of evasion techniques, right? So, or evasions of that IPS system. Now, fragmentation is an example of an evasion technique. Also, encryption, pivoting, using type of stepping stone attacks, and some other ones, that are out there. The good news is that next generation IPS devices perform data normalization in a much effective way, right? They analyze data as a normalized stream instead of actually analyzing data as single or combined packets in the network, right? So this ensures that there's a unique way to interpret network traffic passing through the security appliance or the IPS device. Now, in the following lessons, we will actually cover how to interpret common data values into a universal format. It's important that you have a way to interpret common data values into a universal format and that you actually have a good data model within your organization. So you may ask, okay, so what is actually a data model, right? So what are you talking about? A data model is actually a hierarchical structure mapping of semantic knowledge about one or more datasets. By having a good data model for all your security event data, it will actually allow you to build an assortment of specialized and also very fast queries of those datasets, right? That's why it's actually important for you to have a good data model. Now, in order for you to be able to create an effective data model, you have to first understand the sources of the security event data in your infrastructure. Here I'm actually showing a security information and events management system, or SIEM, that is actually retrieving data from different sources, including IPS devices, firewalls, NetFlow generation devices, servers, endpoints, and syslog from infrastructure devices as well. Depending on how the event data is actually structured from those sources and how different fields within that data are actually extracted, related, and organized, that's how it can actually affect your data model architecture, right? And now the good news is also that there are actually tools such as Splunk and many others that already accept data from well-known security devices and other sources, and this tool allows you to actually arrange that data to have and also get additional fields that allows you to actually do complex and simple searches and field extractions and lookups within your organization. Now, there's also a problem within the industry on the different ways security tools and humans refer to security events, incidents, and related information. This is why specifications like the vocabulary for event recording and incident sharing, otherwise known as VERIS, actually have been created, right? So here I'm actually showing the VERIS website. VERIS was actually originally created by folks from Verizon and other organizations, and actually is a set of metrics designed to provide a common language for describing security incidents in a structured and a repeatable manner, right? The overall of VERIS is actually to lay a foundation on which we can constructively and cooperatively learn from our experiences to actually better manage risk. Whenever you are studying for the CCNA CyberOps SecFun exam, you learn what is the concept of the 5 tuple. But as a refresher, here I'm actually including the 5 elements, right? That's the source IP address, the source port, the destination IP address, the destination port, and the protocol. Now, traditional firewalls typically provide security event logs that are mostly based on the 5 tuple. For instance, a traditional Cisco ASA log may look like this, right? In this example, the ASA dropped a TCP packet that didn't have an associated connection in its connection table. In short, the ASA is actually looking for a SYN flag in the first packet of a TCP connection, and in this case, actually, it was not, and the ASA drops that packet that the SYN flag was actually not set, and there was actually no existing connection for that transaction or for that packet. Now you also see the 5 tuple used in IPS events, right? You also see them in NetFlow records and other event data. In fact, in the exam, you may actually need to differentiate between a firewall log and a traditional IDS event. One thing to remember, and I guess a quick tip, is that traditional IDS and IPS devices actually use signatures. So one easy way to differentiate is by looking for a signature ID, in the output. So if you see a signature ID, then most definitely that event is a traditional IPS or IDS event. And you saw a couple of examples of a syslog message from a Cisco ASA, and that will help you identify, what type of a device log they may be referring to. Threat intelligence is extremely useful when correlating events and to gain an insight of what known threats are actually in your network. And more importantly, DNS intelligence and URL reputation is actually used in many security solutions, including the Cisco Firepower Appliances, FTD, or the Firepower Threat Defense solution from Cisco, Web Security Appliances, or WSAs, email security appliances, and even cloud services like the Cisco CWS, right? Cisco Web Security. Now, for instance, you can correlate security events based on threat intelligence to identify communications to non-malicious command and control servers based on DNS information. Here I'm actually showing different security threat intelligence events in the Cisco FMC, or the Firepower Management Center. You can see that a host is actually communicating to a known command and control server based on DNS threat intelligence data. And again, you can actually use this threat intelligence and DNS information with many other security events, and also things like NetFlow. Log analysis is actually the process to parse and analyze a log file from a web server, right? And you can actually use this to know about indicators about when, how, and by whom a web server or a website is actually visited, right? Now, the data extracted from the log files can also be stored in a database, allowing for many reports to actually be generated on demand. There are several security event management platforms like Splunk and Greylog that can collect and process web server logs, and they actually do a lot of this type of correlation for you in a very effective manner, right? Now, features supported by log analysis packages may include things like hit filters, which actually use pattern matching to examine the selected log data. Now, there's different type of log data that includes, things like the number of visits and number of unique visitors, the visit duration, and when was actually the last time that the user or that web service was actually visited, and what are the actually authenticated users, when they were actually last authenticated to the system, the days of the week and rush hours of that web server, the number of web pages that actually were viewed, the most viewed entries and exit pages, and also file types within the web server, right? Also the operating systems and the browsers that are used by the users, right? The HTTP refers and search engine key phrases and keywords used to actually find the analyzed website, and many other things like HTTP errors, right? Now, two very popular web servers are the Apache HTTPD server and Nginx. Now, the Apache HTTPD server provides a very comprehensive and flexible logging capabilities, right? Nginx also provides a very similar log structure, and by default, Nginx and Apache writes activities and information into two types of logs: the error log and the access log. The error log is where the web server records any type of errors, right? Anything that actually it doesn't think that is actually quite right? Sometimes you will also see warnings in there that don't indicate a problem, but advise you that a particular event or configuration may actually cause some problems later, within the system. Now, the access log is where your web server records all the visitors to your site, and there you can actually see what files the user is actually accessing, how the web server responded to request, and other informations like what kind of web browsers the visitors are using, and also the operating systems of those systems, right? Now, before you can read your logs, you'll need to find them, right? You need to know where those logs are. So to find the error log, look in your main Nginx or Apache HTTP config files. However, by default, all the logs typically are stored under var log in your system. So under the /var/log directory, right? Here's an example of the Apache logs. You can see the access and the error logs here. And as we mentioned before, in the access log, you can see what files the user are accessing, how the web server responded to request, and other types of information like what kind of web browsers the visitors are actually using.